All right, good morning. Today we are continuing on with Unit 5, doing CO30. I can create a function table. Before Christmas break, we worked on graphing and being able to put those points on the coordinate plane. We worked on finding the slope of a line. Now we're going to be doing a function table. Yesterday we were working on those patterns. In the function table, you're going to follow those patterns. And then tomorrow we're going to work on graphing the function table. So it's all building on each other. So yesterday's was kind of easy with those patterns, and we're going to see how those patterns tie into our function table. So a function is a pairing of each number in a given set with exactly one number in another set. Starting with a number called an input, the function associates it with exactly one number called an output. So if we have the input for this function table, we have an input of 1, we get an output of 2. When we have an input of 2, we get an output of 4. When we have an input of 3, we get an output of 6. And when there's an input of 4, we get an output of 8. So thinking back to what we talked about yesterday with our patterns, can you tell me what the rule is of this function? What is our pattern that we're following? What do we call it? Instead of saying add it by itself, multiply by 2. So our rule here is to multiply by 2. We're multiplying our input by 2 to get our output. So that's how we're tying in those patterns from yesterday to how we work with a function table. So the input is a number on which a function operates. An input value is the domain of the function. The output is the number produced by evaluating a function using a given input. An output value is in the range of the function. So to get the output, you have to do your rule. Domain of a function, the set of all input values for the function. And the range of a function is the set of all output values of the function. So the domain is the input, the range is your output. So for this function table, our range was 2, 4, 6, 8. So let's look at evaluating a function. It's not going to move up with my finger. So evaluating the function. If y equals fx when x equals 7. So we're going to write a rule for that function. If y equals fx, what does that mean when we have a number right next to a letter? What operation are we going to do? If that number's right next to the letter, we've got the f right next to the x. Tristan? Multiply. So if it's fx, we're multiplying by 5. And then it says when x is 7. So our rule for the function is we're multiplying by 5. We're going to substitute 7 for x. So it becomes 5 times 7. And we're going to multiply it, and we get 35. So that's how you evaluate your function. You figure out the rule, multiply by 5. What are we multiplying by 5? We're going to x, and we're saying x is 7. So it's 5 times 7. So now we're going to use that to make our input-output table. So here we want the function to be x minus 1.3. So what's our rule? What do you think the rule of that function table is going to be? If it's x minus 1.3, what are we going to do to every input, to every x? What are we doing to every one, Will? You're on the wrong one. Y equals x minus 1.3. So what are we doing every time? To every x, what are we going to do to it? subtract 1.3. So that's our rule. Every input, we're going to subtract 1.3. So we're going to use the domain 0, 1, 2, and 3. What did we say the domain was? Look on your paper. What's the domain? Nick?
The input value.
The input. So where we have input, we're going to write our domain. 1, 2, 3. Now we're going to do our substitution. We've got y equals x minus 1.3. So we're going to substitute that x in there. So 0 minus 1.3. What does that become? What is 0 minus 1.3? Nick?
Isn't it negative 1.3?
Our output then is going to be negative 1.3. So you have your input, you do your function, you substitute that input, that x, in for the x in that function, and then you get your output. So if we look for the 1, we have y equals 1 minus 1.3. What is my output going to be? Brielle? Yeah, negative 0.3. 1 minus 1.3 gives us that negative 0.3. Now we have our 2. So we're going to substitute a 2 in for x. Oops. 2 minus 1.3. What is 2 minus 1.3? Aiden?
Negative 0.1.
Careful. We have 2 minus 1.3. We want to line up those decimal points when we subtract or add. So if we have an empty space, we're going to put a 0. Can we do 0 minus 3? So we're going to have to borrow our 10 over there. So now we have 10 minus 3 is 7. Bring down my decimal point. 1 minus 1 is 0. It's a positive 0.7. Make sense, Anna? Now we're going to substitute in our 3. Y equals 3 minus 1.3. So again, you're going to want to set it up, lining up those decimal points, making sure you fill in a 0 for the empty space. And we don't do 0 minus 3. We have to borrow. So 10 minus 3, 7. 2 minus 1 is 1. It is a positive. Then it says, what is the range of the function of these outputs? So what is our range? What do we have to look at? Nick?
We have to look at the output.
Yeah, our range is the output. So it'll be negative 1.3, negative 0.3, 0.7, 1.7. That is our range. It is our output. Let's look at example 3, writing a function rule. Write the function rule for the input-output table. So look at our inputs. We have negative 2, negative 1, 0, 1, 2, 3, 4. We have our output, 0.5, 1.5, 2.5, 3.5, 4.5, 5.5, 6.5. What are we doing every time? When we're going from our input to our output, what is the pattern that we are following? To go from negative 2 to 0.5, -1 to 1.5, 0 to 2.5. What are we doing, Lily?
Adding 2.5.
Yeah, so that's our rule. Our rule for this is add 2.5. So to make it into our function, we would say y equals x, which is our input, plus 2.5. So instead of just saying add 2.5, we're going to make it into that function. Y equals x, our input, plus 2.5. So it's what we've been doing. We're just making it sound more mathy. We like it to sound mathy. It makes us sound very smart because we are smart. So instead of just saying the rule is add 2.5, we're going to say what that entire function is. Y equals x plus 2.5. So I got you guys there? You following?
Yeah.
All right. Next one, solve a multi-step problem. Using the input-output table, write the function rule, and then we're going to evaluate the function to find the output if the input is 9. So first things first, we need to figure out what our function rule is. So how do we go from 1 to 2, 2 to 4, 3 to 6, 4 to 8? What are we doing each time, Ryan?
Multiply by 2.
We're multiplying by 2. So our rule is multiply by 2, but we want to make it a function. So we start with that y equals, and instead of saying x times 2, how do I write that? When I'm using a variable, a letter variable, how should I make that look? Instead of saying x times 2, Tristan? We should put them right together. You are correct. We don't put it as x2. That looks kind of goofy. We always put the number first and the variable second. So 2x. 2x means multiplying by 2. So then we have to evaluate the function to find the output if the input is 9. We're not going to make our function table follow the pattern all the way up to 9. Can we solve it for just the input being 9? Who thinks they know what the answer is? Nick?
18.
How did you get that?
Because it's multiplied with 8. 9 times 2 is...
Yeah, we don't have to fill in the table all the way up to 9 because we know that function rule. We can substitute that 9 for the x right there. And then we can say y equals 18 because 2 times 9 equals 18. So figuring out your function rule saves you time when you're having to figure out something that's far away. Could you tell me what the output is if our input is 20? Will?
20.
Yeah. Look at how fast we did that. So we don't have to complete the table each section at a time. Once you figure out what the rule is, you can plug in what your input is into the rule to figure out that output. And it makes it a lot easier. Do we have any questions on our function tables? Okay, we are going to sign off with our friends at home. Our homework for today is workbook page, oh goodness, workbook page 95, 96. So we're going to work on those functions on 95, 96, and I hope our friends at home are having a good day.